Same question again. Let's ask one more thing about this question. When we tried to look at the free body diagram of just the person, we had a normal force and a gravitational force. Those two cancel out because there's no acceleration vertically. So in the horizontal direction, there's the frictional force of the ground pushing. Then there's the car pushing as well. So those two things are horizontal. Can we figure out what the force of the car on the person is? Now that we know some other information, we know how big F is. So can we do that? So let's try sum of forces. We only care about the x direction. This is for just the person. Over here, this was for the person plus the car. Just on the person. So the sum of forces on the person are, well, let's see, there's F here. Frictional force from the ground, that direction, minus, now this is in this direction, so there's going to be a minus some force from the car. So minus a force from the car, and well, that's it. So those are the sum of the forces. That's also equal to MA, right? Sum of forces equals MA. So if we're looking at only the person, this should be the mass of the person times the acceleration of the person in the x direction. So can we solve this now for force of the car? I know everything in here except for that one. So if I rearrange this, I'll get minus force of the car equals mass of the person, 70 kilograms, acceleration, 0.286 meters per second squared, that's and then minus F. Subtract F from both sides. And F was 220 newtons. So that means the force of the car on the person is 200 newtons. So this is the force from the car on the person, 200 newtons. And that's really interesting because a 70 kilogram pushes a 700 kilogram car with a force of 200 newtons. So if the person pushes the car with a force of 200 newtons, the car pushes back opposite direction. So this was the force applied from the person, was this way. Force from the car opposite way. So the car pushed back on the person with exactly the same force that the person pushed on the car. That's going to be true in every case. Forces come in equal and opposite pairs. If one thing is pushing on another, that other thing is pushing back with the same force. If you pull on something, that other thing is pulling back on you with the same force. In this situation, the things are accelerating. And so even if it's accelerating, it's the same force. If I'm holding up a pen, the force of that pen pushing down on my hand is the same as the force of my hand pushing up on that thing.